All right, so we're going to begin our discussion on area of a sector and arc length. This video only covers arc length. All right, in the next video, I will talk about the area of a sector. So arc length, what is the difference between the measure of an arc in degrees and its arc length? Well, if you notice, I have two circles here, one large and one small, and on each one of them I have drawn a diameter, and we all know that a diameter creates a straight angle or a 180-degree angle, which means that its arc that is associated with it creates a semicircle of 180 degrees. It doesn't matter how big or how small the circle is, the measure of a semicircle is always 180 degrees. So the degree measure tells you how many degrees around the circle it goes, but its length tells you how long it would be if we straightened it out. So if I took on the small circle a piece of string from A to B and I lifted it up and I placed it down here in a straight line, and then I did the same thing with this circle, and I had a string that went from D all the way around to C, and I laid it out straight, you would definitely see that the length from C to D is much longer than the length from A to B. So those would be the lengths of the arc, not the degree measures of the arc. Okay, so there's a difference. Yeah, and a semicircle has a degree measure of 180. Doesn't matter how big or how small the circle is, but the length of the arc will change. Okay, so let's talk about how to find arc length. So to find arc length, first of all, it's a fraction of the circumference of the circle. It's just a piece of the circumference. It's not the whole thing. So the way we have to do it is we have to set up a ratio. Okay, so the ratio of the length of a given arc to the circumference. So the ratio of the length of the arc over the circumference is equal to the ratio of the measure of the arc to 360. So the arc length over the circumference equals the measure of the arc over 360. Now remember, circumference is a distance all the way around a circle, so don't forget that. And the formula to find a circumference is 2 pi r, or diameter times pi. So instead of putting circumference here, I just put 2 pi r in instead, because that's what circumference is. And then we're going to take this formula, we're going to make it a little bit easier to use. So I'm going to multiply both sides by that 2 pi r and get this in terms of arc length. Okay, so the arc length equals 2 pi r times that measure of the arc over 360. Okay, so this is the version that we're actually going to use the most. Okay, 2 pi r, or circumference, times the measure of the arc over 360. All right, so let's work out a few examples and see how this actually works. All right, so I have a circle here, and the circle has an arc that we're trying to find the length of. Okay, so we're trying to find the length of the pink arc. I know the measure of the central angle is 80, and I know that the radius is 9. So I'm going to use this formula right here, and for arc length, since that's what I'm looking for, that's my x. I'm going to put in 2 pi times my radius of 9 equals 80 over 360. Now remember, this is a central angle, and central angles equal the measure of their arc in degrees. So if this is 80-degree angle, then this is an 80-degree arc. So that's where I get that 80 from right there. And then we're just going to simplify this down a little bit, and we're going to solve for x. So 2 times 9 is 18, and if I take 80 over 360 and divide both of those by 40, I get 2/9. So I just simplified that fraction down. And then I notice that 9 and 18 will go into each other. 9 will go into 18 2 times. So I end up with 2 times 2 times pi, or 4 pi. Now if they ask you to leave your answer in terms of pi, then you can just leave it just like that, 4 times pi. If they want an actual answer, then I would put that in my calculator, and you'll end up having to round your answer, of course. So you're going to use approximately 12.5663 would be your answer. Okay, so that's how you work out one of those. Let's look at a couple of other examples. So on this example, they're asking me to find their circumference. And they give me the measure of the arc, or the arc length, I'm sorry, and they give me the measure of the angle. okay? So what we're going to end up doing here is I need to find the radius in order to find the circumference, because remember, circumference equals 2 pi r. So I need to know what the radius is. So I'm going to set up my formula. Arc length equals 2 pi r times the measure of my arc over 360. And I'm going to fill in what information they gave me. They gave me the measure of the arc, 4.5. I know 2 pi r. 45, I get that from the central angle, which means that the measure of the arc is 45 over 360. And I'm going to take this and I'm going to simplify it all the way down till I figure out what r is. Then I'm going to use r in this formula over here. All right, so let's see if we can simplify a little bit. So I know that 2 times 45 is 90, so I can go ahead and do that. And I know that 90 over 360, well, 90 will go into 360 4 times, so that simplifies to 1/4. So now I have pi times r times 1/4. Well, I want to get rid of that 1/4, so I'm going to multiply by its reciprocal, which is 4. So I'm going to multiply both sides by 4. 4 times this 4.5 is 18. That leaves me with pi times r. Okay, so I have 18 equals pi times r. And I want to get rid of the pi, so I'm going to divide both sides by pi. So my radius equals 18 divided by pi. I'm going to leave it just like that for just a minute, okay? Then I'm going to come over here. So remember, I'm trying to find circumference. The circumference is 2 pi r. Well, I just figured out that the radius of this circle anyways, is 18 divided by pi. So where my r is, I'm going to substitute in that 18 divided by pi. Well, what happens to your pi's is they cancel out. So you end up with just 2 times 18, or 36 inches. So your circumference is 36 inches. All right, let's look at another example. In this example, they're asking me to find the radius. All right, they give me the measure, or the arc length is 10 centimeters, and they give me the measure of the central angle is 160. All right, so I'm going to use my same formula. Arc length equals 2 pi r times the measure of the arc over 360, and I'm going to solve for the radius. So the measure of my arc is 10. 2 pi r, I don't know what my radius is, but I do know that 160 divided by 360 will simplify to 4/9. Okay, so I'm just going to simplify that down. And then I know that 2 times 4 is 8. So now I have 8/9. I'm just trying to clean it up a little bit and simplify it. Now I want to get rid of that 8/9. So to get rid of 8/9, remember, you multiply both sides by the reciprocal. The reciprocal of 8/9 is 9/8. So multiply both sides by 9/8. That will cancel out these 9s and these 8s and get rid of your fractions on the right side. On the left side, I would put 9 divided by 8 in parentheses in my calculator and multiply that by 10, and you'll get 11.25. On the right side, I still have my radius times pi. Okay, so I'm down to this part right here. I have 11.25 equals radius times pi. Well, remember, I'm trying to find the radius, so I need to get rid of the pi. So I'm going to divide both sides by pi, which means those pi's will cancel out. That leaves me with the radius, and if I put 11.25 divided by pi in my calculator, I get approximately 3.6 centimeters. Okay? All right, let me show you one last example. And this last example is pretty typical. It will give you an odd shape like this. This looks like a half a basketball court, and it wants you to find the perimeter all the way around it. So typically they will only give you a radius, or they'll give you the measure of this side. Okay? What you need to realize is that if they give you the radius, that the distance all the way across, or the length of this side over here, is twice that. So if you know the radius is 6, then you know that the length of this side has to be 12. And we are assuming that this is a square, so this would have to be 12, and that would have to be 12 as well. So the measure of the blue portion of my shape is 12 times 3, or 36. Now to find the measure of the green portion, I'm going to have to find the measure or the arc length of the green, okay? This is where our formula comes in. We need to find the arc length of the green portion, all right? And I know that that is 2 times my radius, well my radius is 6, times the distance around here, since this is a diameter, it goes through the center, then I know that the measure of the arc in degrees is 180. It's a semicircle. So 180 divided by 360 would get me my whole formula. Well, 180 will go into 360 1/2, right? Twice. That gets me down to 1/2. 2 times 6 is 12. So again, I'm just cleaning up my formula and simplifying it a little bit. Then 2 will go into 12 6 times. So I end up with x equals 6 pi. And if I put that in my calculator, I get approximately 18.85. But remember, we're looking for the perimeter of the entire shape. So I need to take the blue portion, which is 36, add it to the green portion, which is 18.85, and I get approximately 54.85.